This is a short video we put together for combating COVID-19. Contact tracing is a very active research area. UK, Australia, Europe, Singapore, Apple and Google have all come up with their own solutions, but they all have common issues. They only work with mobile phones, the indirect chain is not considered, and Bluetooth unreliability is not addressed.
Our end-to-end solution has mobile app for registration and proximity scan, database for storing the data, RSSI model for Bluetooth unreliability, analytics and dashboard for visualizations, registration is a simple 10 seconds process, and here is the demo.
We have used Google Cloud Database to store the user registration and proximity data. Our first experiment was capturing the proximity data using the mobile app we built. We went for a 1-hour walk over a few days to capture proximity Bluetooth devices. During this walk, we went into busy places like supermarkets and coffee shops. Part of the journey was completed using public transportation.
To overcome mathematical and unreliability issues with RSSI, we took over 1,000 RSSI meter readings using heterogeneous devices. Using the measured data and for modeling RSSI, we looked into linear, polynomial, and generalized additive regression models. Finally, we settled down with the polynomial of degree 4 regression model for transforming RSSI values to distance in meters.
Using the RSSI model in analytics, we calculated distance, time spent duration, average distance traveled, and the number of devices at any specific point. We built a dashboard for visualizing the contact network. The filters on the dashboard are distance between the patient and other people, time the patient spent with others before diagnosing, date and date offset. When a person is tested positive on a specific date, the dashboard helps precisely narrow down the contact network by applying date and date offset filter to see the past 14 days of history. Distance traveled and the number of Bluetooth devices and the GPS map provides richer context in deciding whether or not alerts should be sent. Here is an example how the distance filter was used to narrow down the contact network. As the distance between the people reduces, the contact network shrinks. Here is another demo how the time spent duration was used to narrow down the contact network. As the time spent increases, the contact network shrinks.
Here are two examples. Example 1 shows how by combining GPS map, average distance traveled, and number of proximity devices, one can interpret whether the person is walking, cycling, or driving. Example 2 shows how by combining GPS map and number of devices, one can interpret the contact surroundings, like crowded or uncrowded places. Contact tracing purely based on Bluetooth is not enough. Through experiments and visualizations, we proved that a deeper contact context is required for effective contact tracing. As a next step, we would like to use probability and decision-based tree models for automating alerts based on context. Thank you.